Okay, so today we're going to talk about square root functions and inequalities from section 6.3. I'm going to read through the notes and then we'll do some examples and you'll be ready to work on your assignment. A square root function is going to have a limited domain and range. The radicand of a square root function must be greater than or equal to 0. The range will have to be determined by the values outside the radical. The range is easier to determine by looking at the graph. Remember that x-intercept is the value for x when y equals 0, and the y-intercept is the value of y when x equals 0. So we're going to learn how to graph a square root function and a square root inequality. But first, let's look at the standard form of a square root function. It looks really similar to other graphs that we've worked with over the year. You have your A in front of the primary part of the equation, and this A makes the graph either open up or flip over. If it's positive, it opens up. If it's negative, it flips over. The number also affects the vertical stretch or horizontal stretch. Inside the radical, the H makes the graph move left or right, and it always goes the opposite direction of the sign because the standard form is x minus h, so that means that if it's x minus a number, it's actually a positive number. That negative is part of the equation. Then you have this number outside the radical that moves your graph up or down. Okay, so the first part of this says to graph, give the domain and the range, the x and y intercept. Okay, so one thing that you want to know about these graphs before we start working on this is that when you type your equation into the y equals screen of your calculator and graph it, it's only going to graph part of your equation. Actually, what this would look like if it graphed both parts, just in general, is you would have this sideways parabola. But that is not a function because when you try to use the vertical line test, it intersects two parts of the graph at the same time. Because of that, they only graph one part at a time. So if you have a positive radical, whatever that might be, you're going to be graphing the top part of the sideways parabola. If your radical is negative, then you're going to be graphing the bottom part. Okay, so let's look at your first example on your paper. And we are going to graph this and then state the domain and range and find the x and y intercept. Y equals the square root of 3x plus 4. Okay, so the first thing you want to do is figure out what the x value is where the graph is going to start. And the inside part of your radical is going to determine that for you. So whatever this inner part of your radical is, we're going to take that polynomial, or binomial, whatever it could be, set it equal to 0, and solve for the x. So in this case, you're going to subtract the 4 and then divide by 3. So x equals negative 4/3. So what this means is, if I substitute negative 4/3 inside this radical, or radicand, this whole value inside the radical would be a 0. Okay, so I cannot have anything less than negative 4/3, because if I plug in something less than negative 4/3, I'm going to get a negative radical square root, which is going to be an imaginary term. So you could try to type in something like negative 2, negative 3, something that's less than negative 4/3, and you'll get i's for your answer. So this is where the starting point is for your x coordinate on the graph. So that's my most important point. That's also going to help me with the domain when I write the domain for the graph. Now I've got to find the y coordinate for this x value. So if I plug that in, and solve, 3 times negative 4/3 is going to be negative 4 plus 4, so that's going to be 0. My y value is 0. So this is my starting point for the whole graph. That's the most important point. So I want to graph that first, and then I'm going to find other values. Okay, so negative 1 1/3, 0 is right here. And I want to choose values that are on the right side of that value for x. I don't want to choose x's that are on the left side because that will give me imaginary numbers inside the radical. So now what I want to do is I am going to look at my calculator and I'm going to let that help me get other values for my x and y. Okay, so let's go to the y equals screen. I'm going to clear that out. I'm going to type in a square root. You can use the second function of the x squared button. So I'm going to push second x squared and then type in the 3x plus 4, and I'm going to close the parentheses just to show that all of that's going to be inside the radical. And then graph. My window is not in standard form right now, so I need to change that back to standard. So I'm going to press zoom and then number 6, and now it'll graph it for me. Okay, so that's what it's going to look like after I get some more points. So to get those values, I'm going to go to my table. So I'm going to press second, table, and if I move up, there we go. So you can see anything that's less than negative 1, I get an error for because that gives me i's. But I have a negative 1, 1, and a 0, 2. Okay, so let's graph those on the graph. So I'm going to have negative 1, positive 1, and 0, 2. And then I can just draw my arc. And I do want to make it kind of a curved line because it is half of a parabola. And there's my graph. So now I'm going to talk about the domain and the range. Now your domain is the restriction on your x value. Okay, so that's left and right. And again, like I said before, this beginning point tells you where the domain is going to start. You're not going to have any values less than this negative 4/3, or you're going to get i's in your radical. So your domain has to stay greater than negative 4/3. And we're going to write it in set builder notation. All values of x, so that x is greater than or equal to negative 4/3 is going to be the domain. And then your range, we're going to use the y value of our starting point, and the range is up and down. I'm not going to have any y values less than 0. It's all going to be greater than 0. And I want to use set builder notation again. So all values of y, so that y is greater than or equal to 0. And then if they ask for the x-intercept and y-intercept, the x-intercept is where y is 0. So that x-intercept is at negative 4/3. And the y-intercept is where x is 0. So that's going to be at positive 2. And there you go. So let's do one more, and then we'll move on to the inequalities. So let's look at number 2. And we are going to find the graph. We're going to graph the problem. We're going to find the domain and range and the x and y intercept. Now sometimes you're not going to have an x or a y intercept, and if that's the case, if it doesn't cross an axis, you can just say none. Okay, so you go ahead and work that problem at your desk, and I'll do it up here. Let's see what everybody gets. Okay, so when I typed this into the calculator, I put double parentheses around the fraction 3 over 2, so the calculator would keep that all together times x, and it wouldn't just put the x times the denominator. Okay, so you got to be careful about putting parentheses in the right place, and then I ended it with a parenthesis to keep everything together inside the radical. And here's my graph, and looking at the table of values, all of my y's are decimals, and that's okay. I mean, that's just the way it's going to be. So you're not going to easily find some whole numbers for your y, so we can just use, like, for our graph, 2 and about 1.4, we can round it, and then 4 and about 2.2 for the y. So I'm just getting those off the table after I entered in the equation. So there's my graph. It has a definite starting place, and it goes only one direction. You're not going to have a graph where it's going both directions. Okay? So your domain, you get that from your starting point. All values of x so that x is greater than or equal to 2/3. And your range is the y value from the starting point. In this case, it's going above again. The only time it might flip over is if there's a negative in front of your radical. So the range is going to be all values of y so that y is greater than or equal to 0. So if it did flip over, it'd be less than or equal to 0. Okay, and there's not going to be a y-intercept, but you do have an x-intercept of 2/3. Okay, so let's move on to the inequalities. Let's look at number 3. The only difference between the inequalities and the two problems that we've already done is that we're going to shade for one thing, and the line is either going to be dotted or solid. So everything else is the same. I want to start out taking the radicand part, only the part under the radical, nothing else, setting that equal to 0, and solving for x, and that is going to give me my x coordinate where my graph will start. So the x is 3, so I'm going to plug my value back in. And just to solve, I'm going to say that y is equal to, just for solving purposes, but that's going to be 0. So I'm going to start with that point right here on my graph, and I want to find a couple more points. If you want to think of your own values, that's fine, but just, for convenience, you might want to get your table from the graphing calculator. I'm not going to worry about the inequality whenever I'm graphing it here. I just want points to put on my graph, so I'm just going to look at the table. And I have 5, 2, and 6 and 2.4. Okay, so here's another point, and then one more over a little bit further up. Okay, so there are my points. Now this is only less than, so I am going to have a dotted graph. And now I need to decide if I'm going to shade above or below. So doing that, if I want to choose a point to substitute in, I don't want to choose any points to the left side of the starting point, because that will just give me an I inside the radical. I can't really use it. It's not going to tell me anything. So I'm going to choose, like, 4, 0 looks like a good point. My x is 4, my y is 0, and I'm going to substitute it in to my original inequality. So you got 0 less than square root of 2 times 4 minus 6. 0 is less than square root of 8 minus 6. So 0 is less than radical 2. And that is true. 0 is going to be less than radical 2. Radical 2 is 1.4 or something like that. So wherever that point was on your graph is where you want to shade. And we're going to keep all of the shading to the right side of that beginning x value, because your range does not include anything to the left of that. And that is your graph. You don't have to worry about domain and range because inequalities don't use domain and range.